Today we'll start with the invertible functions, and let f is a function. Let f is a function from a to b, which is 1, 1 and down to. And let take the set A, set B. A contains the elements A, B, C, and B, the set contains the element 1, 2, 3, and there is a relation between A and B, where A relates to 1, B to 2, and C to 3. Then what we find, F consists of A, 1 and B, 2 and C, 3. Also, another function, that is G, exists between B to A, such that it is 1, 1 and 1, 2 also, and here what we find here, the G contains 1, A and 2, B and 3, C. Then what we find here, G is here, G is the invertible function, G is the inverse, G is the inverse of F, and we write G is equal to F inverse. Now coming to definitions. If f is a function from a to b is bijective, that means 1, 1 and on 2, then f is called invertible, and there exists a function g from b to a, such that f of x is equal to y implies and implied by f inverse y is equal to x. Then this f inverse is g, and here g is called inverse of f, and we write g is equal to f inverse. Now coming to second definition. The second definition is the composition function and the identity function. That is, if f is a function from a to b, such that g is a function from b to a, and FOG is equal to IB, a composition of f and g is the identity function on B, and GOF is equal to IA, then G is called inverse of F, and we write G is equal to F inverse. These two definitions are equivalent, and there are some important observations. Number one, if f is bijective, then F is invertible implies that F inverse exists. Please student, note down this one. If F is bijective, then F is invertible implies F inverse exists. Number 2, if F is 1 1 and onto implies that F inverse is also 1 1 and onto. Please note down this statement observations 1 2, then I will switch over to the other observations. So if F is bijective, then F is invertible, F inverse exists. If F is 1 1 and onto implies that F inverse is also 1 1 and onto. Now number 3, range of F is equal to domain of F inverse, then range of F inverse is equal to domain of F. This is a very important observation. Now coming to, if F and G are 1 1 and onto, then G of F is also 1 1 and onto. G of F inverse is equal to F inverse. Please note down these are the properties asked in MCQ of JEE and board. And number 5, F inverse is unique. Now these are the important properties, observations, very important, coming as a MCQ on board and entrance. And dear student, please remember this, and practice makes a man perfect. Your perfectness lies how long you correlate with the things that you are coming across in various MCQ questions. Now coming to very important observations. Here fx and f inverse x are imaged. The graph of fx and f inverse x are imaged with respect to y is equal to x. Now we will see now Now, very interesting fact is that your exponential function and natural logarithmic, they are inverse to each other. I will derive now. They are inverse to each other and they are image with respect to one another. They are inverse to one another with respect to the line. Just to see the mirror reflection, and they are symmetric. You can fold it along this line. Let us see how they are correlated. Y is equal to e per x, taking log of both these sides, then log of y is equal to x, and now interchanging x to y, what you get? Y is equal to log x base e, and this y is nothing but f inverse x. So what you find here, this y is nothing but f inverse x. I derive this one. So this is the image of this function, and this is the image of this function. So the very important property, when a function is invertible, the inverse exists. Invertible means one and unknown two, and their image with respect to a line, their image of each other. And now coming to the problem, let us see a problem. This problem has come in the board 2017, and it's a 6-mark question. And f is a function from r minus 4 by 3 to r minus 4 by 3, where fx is equal to 4x plus 3 by 3x plus 4. What to show? F is bijective, means 1, 1 and on 2. Find f inverse 0. Find x such that f inverse x is equal to 2. Let us see the problem. Now, coming to f is bijective. Now, you know that I have discussed in my first video, 1, 1 function. F is bijective means you have to show 1, 1 then on 2. If images are equal, then objects are equal, elements are equal. Let fx1 is equal to fx2, where x1 comma x2 belongs to r minus 4 by 3. Now 4x1 plus 3 by 3x1 plus 4, 4x2 plus 3, 3x2 plus 4. By cross multiplication, 4x1 plus 3 into 3x2 plus 4, that is right hand side 4x2 plus 3 into 3x1 plus 4, and 12 x1 x2, 16 x1, 9 x2 is equal to 12 x1 x2, 16 x2, 9 x1, 12. Now 12 cancel, and 12 x1 x2, 12 x1 x2 cancel. Now coming to 16 minus 9, 16 minus 9, that is 7x1, and also 7x2 implies that x1 is equal to x2. So we have taken here the images are equal and we get objects are equal. So it shows that f is 1, 1. Now coming to onto here y is equal to, as you do it in finding the range of a function, y is equal to 4x plus 3, 3x plus 4, and by cross multiplication we have to express x in terms of y, that is 3xy plus 4y, 4x plus 3, and 3xy minus 4x, 3 minus 4y. Taking x common, that is 3y minus 4, 3 minus 4y, and you get x is equal to 3 minus 4y by 3y minus 4. Dear student, here the most important that after in onto function, after expressing x in terms of y, we have to say that to every element in the codomain there is pre-image. Now coming to here, this y here for y belongs to r minus 4 by 3. That means in the set of real number 4 by 3 is not there. So the denominator exists. That means for every y belongs to codomain, there exists x belongs to domain. So it implies that f is onto. It implies that, so 1, 1 and onto. So it implies that f is bijective. Now coming to the other part of the question. Right. Now after proving the function to be bijective, find f inverse. The steps to find f inverse. Hello, we have in the previous onto expression we have find x in terms of y, and now when you have to find, remember my dear student, when you have to find the inverse of a function after expressing in terms of y, as their image, the inverse function and the function inverse to each other, we can interchange. So interchanging x and y, that means x will be y and y will be x. This y is nothing but f inverse x. So f inverse x, easy way to find, remember. Now what is f inverse 0? That is f inverse 0, we put it here, 4 into 0 minus 3 by 4 minus 3 into 0, that is minus 3 by 4, we have done it. And fourth one, f inverse x is equal to 2, f inverse x, that is 4x minus 3 by 4 minus 3x is equal to 2, and by cross multiplication 4x minus 3, 8 minus 6x. So by converting 10x is equal to 11 and x is equal to 11 by 10. This is the 6-mark board question, and while we check the copies in the nodal center, we look at the students proving 1, 1 and onto. In case of onto, we check how the student write the elements of the codomain are the range, are the images. There we check it. Dear student, passing through a difficult phase of life, facing unprecedented challenging moments, we are born with special quality to rise over any problems to come on our way. We should not dampen our spirits. Use this time to learn, and this video comes to an end. I hope you have liked this channel, and your likeness, sharing gives me innovative ways to think how to engage you, how to use your time properly for the coming examination. Thank you.